Hey everyone, welcome back for another deep dive. Today, we're going driverless.
Oh, cool.
Yeah, I was thinking about it, right? Like, imagine you're in LA
Okay.
in a driverless car, and you come to a four-way stop.
hmm
How do those things actually work?
Yeah, that's a good question. I mean, it's not as simple as it seems, right?
Right, so we found this article, and it breaks it all down.
Oh, cool. Which one?
It's from datapro.news. It's called Driverless Vehicle Data Engineering.
Okay.
And they actually dive into,
Yeah.
like, how Waymo, one of the big players,
Yeah.
how they handle this whole four-way stop situation.
A classic scenario, right? Everyone's
Mm.
been there. You get to a four-way stop and you're like, okay, who goes first?
Exactly. So it's not just like first come, first served with these cars. There's a lot more going on.
A lot more. You said they use Waymo as an example.
Yeah. So they lay out Waymo's approach in 3 steps. Sense, solve, go.
Okay.
It's almost like, how we drive, but with a whole lot of extra tech.
Yeah. Amped up, right? Like on steroids or something.
Totally. So first up is sense. That's
Mm.
all about the car's perception system.
Okay, the senses. So how does it, like, see the world?
Well, Waymo uses a bunch of different sensors.
Right.
It's like giving the car like superhuman senses or something.
What, can it see through walls now?
Huh? Not quite. But it gets pretty close.
Okay, I'm intrigued. What do they use?
So they've got LiDAR, which is kind of like a 3D mapping system, and it can see objects up to 300 meters away.
Wow, that's impressive.
Yeah. But here's the thing. LiDAR is awesome for mapping the environment,
Uh-huh.
but it doesn't really tell you what those objects are.
Oh, right. Like it can tell you there's something there, but not if it's a tree or a car or whatever.
Exactly. And that's where the cameras come in. They capture all the visual details like traffic signs, lane markings, other cars, all the things we use when we drive.
Makes sense. So it's got the 3D map from the LiDAR and the visual details from the cameras.
Mhm.
What else?
Oh, and then they've got radar, which is key for like gauging speed and movement, especially when the weather's bad, like in rain or fog.
Ah, yeah, that's smart. So it's like a backup system when visibility is low. Covers all the bases.
Right. It's like having multiple eyes on the road.
So it's gathering all this information, but how
Yeah.
does it make sense of it all?
That's where things get really interesting. It's called sensor fusion.
Sensor fusion.
Okay.
Break that down for me.
So basically, it's like your brain taking everything it gets from your eyes and ears, even your sense of touch, and putting it all together.
Ah, so the car is doing the same thing, combining all the data from the different sensors.
Yeah. To make a unified picture of what's going on around it. And to do that, they use some pretty fancy algorithms. Like, have you ever heard of Kelman filters?
Kelman filters. Rings a bell, but maybe you should refresh my memory.
Okay, so basically, they're a way of predicting where something's going to be based on where it's been.
Okay.
So, like, let's say the car sees someone stepping off the curb.
Mm-hmm.
A Kalman filter can help predict where they're going to walk next.
Even if, like, a parked car is blocking them from view for a second.
Exactly.
Wow, so it's not just reacting to what it sees right now. It's kind of anticipating the future.
Exactly. And that leads us to the solve part of the process.
Okay, solve. That sounds like where the real brain power comes in.
Totally. This is where Waymo uses deep learning, which is a type of AI.
Right, I've heard of that. But how does it actually apply to this situation?
Well, basically, the car's gathered all this information from its senses,
Mm,
built this detailed picture of what's happening around it,
yeah,
and now it needs to figure out what to do with all that data.
right. Make sense of it all.
That's where the AI comes in.
So it's like the car's brain trying to understand what's going on and make decisions, but what kind of AI are we talking about?
Well, it's not just one type. It's like a whole team of specialized deep learning models.
A whole team. Okay,
Well,
so each one has a specific job.
exactly. And they all work together. Like one of them is called VectorNet, which is like their secret weapon.
A vector net. That sounds intense. What does that one do?
It's all about predicting how other cars are going to move.
Especially in a situation like a four-way stop where you've got multiple cars all converging.
Exactly. I mean, how do you even predict what humans are going to do behind the wheel?
Right. Huh, right. Human drivers can be unpredictable, that's for sure. So how does VectorNet do it?
Well, it uses something called a graph neural network.
Graph neural network. I'm not familiar with that one.
Think of it's kind of like a social network, but for cars.
Okay, so it's mapping out the relationships between the cars.
Yeah. It helps the car see how all the vehicles are connected and how they might influence each other's movements.
So like if one car starts to slow down for a turn, VectorNet can help the Waymo car anticipate that and adjust accordingly.
Exactly. It's pretty wild.
It's like the car is seeing the ripple effects of everyone's actions before they even happen. That's amazing.
Right. And to help with all that seeing, they use another set of models called CNN's convolutional neural networks.
CNNs, those are like the image recognition champs, right?
Yeah, they help the car see objects, recognize the road layout, even read those traffic signs.
So it's like giving the car its own set of eyes, but ones that can process information way faster than we ever could.
Exactly.
And on top of that, you said they also use RNNs and transformers.
Yep. Those are kind of like the time travelers of the AI world.
Time travelers. Okay, I'm really curious now. How do they work?
They analyze sequences of events so they can help predict what's going to happen next.
So, for example, if a car is braking and signaling a right turn, an RNN could help the Waymo car anticipate the trajectory of that turn.
Exactly. It's like the car is constantly building this story of what's happening on the road
Right.
and using that story to guess what's coming next.
It's like it's reading the road like a book, anticipating the next chapter. That's some serious brain power.
But this brings up another question for me. It's one thing to analyze what's happening right now,
Hmm.
but how does it actually predict what other drivers are going to do, especially at a four-way stop where you have multiple cars all arriving at the same time?
Well, that's where it gets even more interesting. Waymo doesn't just rely on the raw data from the sensors. It actually tries to anticipate human behavior.
Wait, so it's trying to guess what other drivers are thinking? How is that even possible?
They use these things called probabilistic models.
Probabilistic models.
So basically, it's not just guessing. It's crunching numbers, calculating the odds of different things happening.
Okay, so it's like the car is saying, okay, based on that other car's speed and position, there's a 70% chance they're going straight, 20% chance they'll turn left, 10% chance they'll turn right.
Yeah, it's wild, right?
That's pretty amazing. It's like
Yeah.
they're teaching the car to read minds almost. Right. And some of their algorithms actually try to figure out the intentions of other drivers.
Based on what? Like, are they looking at their facial expressions or something?
Not quite, but they look at subtle cues, like how they're positioned in their lane, or even if they're making tiny adjustments to the steering wheel.
Wow. It's like the car is learning to read body language. So we've talked about sensing the environment, understanding what's happening, and even predicting what other drivers might do. But how does it all come together to make an actual decision? How does it choose when it's safe to go at a four-way stop?
That's a great question. And it leads us to the final step in Waymo's process. Go.
Go, the moment of truth. So this is where it takes all that information and makes a move.
Exactly. And it's not just about following a simple set of rules. There's a lot of complex reasoning involved.
Right, because it's not just about knowing the traffic laws, it's also about understanding the nuances of real-world driving situations.
Totally. So, of course, the car knows the traffic laws, right?
Mhm.
Like right of way and all that.
Right, that's the foundation.
But it also has to consider the predicted actions of other drivers, the layout of the intersection, potential hazards.
Even things like pedestrian movements, cyclists, all those unpredictable elements.
Exactly. So it's weighing all these different factors, trying to come up with the safest and most efficient way to proceed.
Kind of like what we do as human drivers, but with a lot more data and processing power.
That's a good way to put it.
Yeah.
And to make those decisions, Waymo uses a combination of different approaches,
Okay.
which we'll dive into after a quick break.
So we've covered a lot of ground here, like how the car takes in all that information from its surroundings, makes sense of it,
Yeah.
and even tries to predict what other drivers are going to do.
Right. It's mind-blowing stuff.
Yeah.
But now I'm curious, how does it actually make the decision at that four-way stop?
Right. Like, okay, it's got all this data swirling around, but how does it pick the right move?
It's decision time, the moment of truth.
Exactly.
So how does it do it?
Well, Waymo combines a few different approaches to make that final call.
So first, it starts with the basics. The rules of the road.
Right, like the stuff we all learned in driver's ed.
Exactly. Those are actually programmed right into the car's system.
Makes sense. So it knows things like right of way and when to yield.
Yeah, it's like having a digital driver's ed instructor built right in.
Haha, that's a good way to put it. But driving in the real world is never that straightforward, is it?
Totally. That's where things get a little tricky.
Right, because we humans rely on experience and, sometimes just intuition.
Exactly. And that's where Waymo uses something called reinforcement learning.
Reinforcement learning. So, like, is the car getting graded on its driving or something?
Uh-huh. You could kind of think of it that way.
Okay, I'm listening. How does it work?
So basically, it uses all its experience, right, from millions of simulated drives and real-world data to learn and get better over time.
So it's like trial and error, but on a massive scale.
Exactly. It's like training a dog with treats, but for a car.
Oh, I see. So it gets rewarded for good decisions and penalized for bad ones.
Exactly. So over time, it learns to make the choices that lead to the best outcomes.
So it's constantly practicing and getting better. That's pretty cool. But how does it actually use all that learning to make a decision in a real-world situation
Yeah.
at that four-way stop?
That's where these things called planning algorithms come in.
Planning algorithms.
Yeah, they basically help the car map out a safe path through the intersection.
Okay.
It takes into account all that information it's gathered,
Yeah.
all that processing, all the predictions.
So it's like the car's thinking several steps ahead.
Yeah, it's playing out different scenarios in its mind, basically,
Oh,
and
wow.
choosing the one that's most likely to be safe and smooth.
It's kind of like playing chess, where you have to think about your opponent's move and plan your strategy accordingly.
That's a great analogy.
So it's not just reacting to what's happening, it's actively planning for the future.
Exactly. And all this planning is happening super fast, like in a fraction of a second.
That's incredible. But it also raises another question for me. All this technology, all this complex decision making,
Yeah.
how do we know it's actually safe? How do we know these cars aren't going to make mistakes?
Right. That's a huge question. And it's something that Waymo takes super seriously.
Good. Because
Uh,
safety is paramount, obviously.
Exactly. The article talks about their commitment to what they call governance and quality assurance.
Okay, so it's not just about building cool technology, it's about making sure that technology is actually safe and reliable out there in the real world.
Exactly.
Well,
And they have this layered approach to safety.
what do you mean by layered?
So they've built this really robust infrastructure, not just for the tech itself, but for like overseeing it all.
Okay.
And they've got teams of engineers and experts constantly monitoring the system, looking for ways to improve it.
So there are actual humans involved in the
Oh,
process.
yeah, absolutely. They're like a whole army of people making sure these cars are behaving themselves.
That's reassuring. But it's not just about monitoring, right?
Right. They have like super rigorous testing procedures.
Yeah, that makes sense. So every software update, every algorithm tweak, it all gets thoroughly tested before it's actually used on the road.
Exactly. They're not just throwing things out there and crossing their fingers.
Haha, right. It's a cautious approach, which
Hmm.
is good. But what about those unpredictable situations that you can't really anticipate in testing? How do they handle those curveballs?
Well, that's where their focus on adaptability comes in.
Adaptability.
They're constantly learning from that real world data, analyzing those unexpected situations, and then they refine the algorithms.
So they're always improving, always learning from experience. That makes sense.
And they have this standardized assessment they use called the Waymo Case Credibility Assessment.
Waymo case credibility assessment. What is that, like a report card for their driverless cars?
Uh-huh, kind of. It's their way of evaluating safety metrics, making sure everything is consistent and transparent.
So they can track how well their cars are performing and identify areas for improvement.
Exactly. It's like a continuous feedback loop.
Constantly learning and getting better. That's impressive. So it's not just about building a driverless car that can navigate a four-way stop. It's about building a system that's constantly evolving, getting smarter and more reliable.
Exactly. It's amazing, right? All this is going on behind the scenes, like a whole hidden world of data, algorithms, and human expertise all working together.
It really is. And it makes you realize that something as seemingly simple as navigating a four-way stop is actually incredibly complex.
Totally. But let's step back for a second and think about the bigger picture.
Okay.
All this technology, all this innovation, what's the point? Like, what are the potential benefits of driverless cars? Beyond, just the novelty of it all.
That's a great question. And it opens up a whole new can of worms. I mean, driverless cars have the potential to revolutionize transportation as we know it. And it goes way beyond just convenience. Think about safety, accessibility, efficiency, and even sustainability.
Wow. That's a lot to unpack.
hmm
Let's start with safety.
hmm
How could driverless cars make our roads safer?
Well, the fact is most car accidents are caused by human error. Driverless cars, theoretically, could drastically reduce the number of accidents, saving countless lives and preventing injuries.
That alone would be a game changer, right?
Absolutely. And then think about the increased accessibility for people who are currently unable to drive themselves. People with disabilities, older adults, those who can't afford a car. Driverless cars could give them a whole new level of freedom and independence.
It's like opening up a whole new world of possibilities for them.
Exactly. And then there's potential environmental impact, optimized driving, smoother traffic flow.
Yeah.
These things could lead to significant reductions in fuel consumption and emissions. We could be looking at a greener future.
So it's not just about changing how we get around, it's about changing the world for the better.
Precisely. But of course, like with any new technology, there are challenges and concerns, and that's what we'll explore in the final part of our deep dive.
So we've talked about how these driverless cars work, the technology, the safety measures,
Hmm.
even some of the potential benefits for society.
Yeah, it's exciting stuff.
It is. But, with any big change, there are always challenges. Like, what are some of the hurdles we might face as these cars become more common on the roads?
Yeah, that's a really important point. It's not all going to be sunshine and rainbows, right?
Right.
One of the biggest concerns people have is about jobs.
Oh, yeah, job displacement. Like, what happens to all the truck drivers, taxi drivers, delivery drivers if their jobs become automated?
Exactly. It's a valid concern, and it's something we need to address head on.
Yeah, we can't just ignore it. It's people's livelihoods. So what do we do? Like, how do we prepare for that kind of shift in the workforce?
Well, for starters, we need to be thinking about retraining programs,
Hmm.
helping people transition into new roles, and we need to be fostering the growth of new industries that emerge alongside this driverless technology.
Right. But there could be all sorts of new opportunities too, right?
Exactly. It's a challenge for sure, but it's also an opportunity to rethink how we approach work and create a more equitable and sustainable future.
I like that. So jobs are one big thing, but what about like the ethical side of all this?
Oh, yeah, that's another huge area. Putting machines in charge of decisions that can have, life or death consequences, that's a heavy responsibility.
It's something we've been grappling with for ages, right? Like the trolley problem.
Exactly. How do you program a car to make the right choice in an unavoidable accident?
It's a tough one. And there are no easy answers.
Definitely not. And it's something we need to keep discussing as this technology develops.
Yeah, involve ethicists, policymakers, everyday people. Everyone needs to be part of that conversation.
Absolutely. We can't just leave it up to the tech companies to decide.
Right. It affects all of us. So
Right.
jobs, ethics, what else?
Well, there's cybersecurity. I mean, these systems are incredibly complex, and the more complex they get, the more vulnerable they could be to hacking or malicious attacks.
Ooh, that's a scary thought.
It is. Imagine someone taking control of a driverless car remotely. The potential for disaster is huge.
Yeah, we need to make sure these vehicles are protected.
Absolutely. Cybersecurity has to be a top priority. We need robust systems and constant vigilance to stay ahead of the bad guys.
So it's a mixed bag, right? Exciting possibilities, but also some real concerns.
For sure. But overall, I'm optimistic.
Yeah.
Yeah. I think if we approach this thoughtfully, with careful planning and an open dialogue, we can navigate these challenges and really harness the power of this technology for good.
That's a good point. It's a reminder that technology isn't just about, gadgets and algorithms. It's about people and how we choose to use these tools to shape our world.
Couldn't have said it better myself.
So maybe the next time we're sitting at a four-way stop waiting for our turn, we'll see it a little differently.
Yeah, think about all the complex stuff happening inside that driverless car across the street.
And maybe we'll start thinking about the bigger picture, the future we're creating.
That's what these deep dives are all about, right? Sparking curiosity, getting people thinking about the world in new ways.
Exactly. And we want to hear from you. What are your thoughts on driverless cars? What excites you? What worries you? Share your thoughts with us.
Because these conversations matter. They help shape the future we want to live in.
That's right. So until next time, keep exploring, keep questioning, and keep those deep dive requests coming. We'll be here, ready to uncover the wonders and complexities of this incredible world.